All right, let's come back together. If you are not done with this maze, I highly encourage you to make this part of your homework assignment. When you come into class next period, we will have a quiz over special right triangles to get us started. Just a little 4 or 5 question quiz. Because special right triangles are definitely a big part of this unit, and I want to make sure that we have a handle on them. And if we don't have a handle on them, then we can do more practice with them. Yep.
Is it going to have the ratios?
It will not have the ratios on it. The expectation is that we come in and we know 45, 45, 90 is going to be in proportion x squared root of 2, 30, 60, 90, x squared root of 3, 2. So just look them over right before you walk in the door, but I kind of need to see how we kind of learn our special right triangles. Let's do a few more examples together. On our next example in our notes, it says that we're going to use a calculator. So this tells me that we're going to have to approximate as we go through this. So I want to make sure all of our calculators are in degree mode. If you're doing your homework and you're using a calculator, whether it's on your phone or the calculator that you can download from Google Classroom that looks like this, just make sure you're in the right mode or you will get some pretty small decimal answers. So just make sure you check that before you do. So I've got our right triangle here, and it's not a special right triangle because I have a 12-degree angle. What's the other angle? What's the measure of angle A? Anybody? What do the 3 angles of a triangle add up to? 180. So what does that last angle have to be? 78 degrees. Questions on that. I just recommend as you go through these questions and it asks you to just fill in any information that you possibly can. Now let's pick our angle that we want to be kind of our reference angle, the angle that we're referring to throughout solving all of these. Which one do you want to use? I don't care. C. So let's circle C, and we're going to label our opposite, our adjacent, and our hypotenuse. I always encourage you to do this. It will take out the whole what number do I need to put when I'm writing all of this down. So let's first solve for opposite. I have adjacent. I want opposite. What trig identity uses opposite and adjacent? Tangent. So that's going to tell me what to use. So the tangent of 12 degrees is whatever our opposite value is divided by 15. How do I solve this?
Get the tangent of 12 degrees.
Get rid of this? Is that what you said? Sure, we can plug that into our calculator and find it. And grab my calculator. Make sure I'm in degree mode. All right, tangent of 12 degrees. We get 0.2126. Now, how do I get rid of the 15? Multiply, right? Right now I'm dividing by 15, so the inverse operation is to multiply. Whatever I do to one side, I must do to the other. And I get out 3.19. That's approximately the length in whatever units this is in for our opposite side. Questions on that? Now, since this is an approximation, I don't necessarily want to use the opposite side to figure out my hypotenuse. So let's go back to our reference angle C. If I have adjacent and I want hypotenuse, what trig identity should I use? Cosine. Yep. So I have the cosine of 12 degrees is equal to 15 over hypotenuse. Now, how do I solve this one? Okay, I guess we can figure out the cosine. 12 degrees. We get 0.978. How do I solve this? Okay, let's take it step by step. How do I get rid of this hypotenuse from the denominator? Yep. Multiply, multiply. So I have hypotenuse times 0.978 is equal to 15. Now I divide by. So I wind up with my hypotenuse is equal to 15 divided by 0.978. And you can kind of keep this written as the cosine of 12, right? You don't have to turn it into a decimal right away. But I get 15. And I get out about 15.34. Questions on how we did that? We could have just as easily chosen 78 to be our reference angle, and then all of these things would have been based off of 78 degrees. Also, we could have, once we found the 3.19, right, we could have used the Pythagorean theorem. I was trying to make sure we practiced, right, and got a different way of solving these, but yes, you can always do that as well. Lots of different ways to solve these problems. Right, let's look at our next example. Find the value of sine, cosine, and tangent for theta. So we have our theta angle. It's been identified. I'm going to circle it to make sure we know what we're looking at. Here's our opposite, our hypotenuse. And we do not have our adjacent. How can we find it?
No.
I don't know theta, so I can't necessarily use trig identities right now. What's the good old Pythagorean theorem? I know, we're going to get so involved into trig that we're going to sometimes forget that, oh, I can just use the Pythagorean theorem. So I get adjacent squared plus 12 squared equals 4 square root of 13 squared. Yep, let's talk about this math here. Okay. 4 times the square root of 13 squared. So this means 4 square root of 13 times 4 square root of 13. What's the square root of 13 times the square root of 13? 13. So I really just have 16 times 13. Right? 4 times 4 times, which is, what is it? 208. 208. Thank you. Subtract. 64, oh, lo and behold, that works out nicely. I have a nice adjacent side. It is just 8. You can definitely put this in the calculator, right? Just make sure if you're using the calculator, you're putting your parentheses in the right place and all that stuff when you're raising it to a power. So now that we have all 3 of our sides and they're all labeled opposite, adjacent, hypotenuse, let's go ahead and fill out all of these different values here. So let's start with the sine of theta. Well, that square root of 13 is going to mess it up, right? It's going to make it a little bit harder. So sine is opposite over hypotenuse. So 12 divided by 4 square root of 13. 12 over 4, that's just 3. And then I still have to get rid of that square root of 13. So I get 3 square root of 13 over 13. Definitely a difference from geometry, us having all these radicals in our answer. Cosine is going to be adjacent over hypotenuse. Go ahead and simplify that before I rationalize my denominator. I get 2 square root of 13 over 13. And tangent's at least nice. The tangent of theta is 12 over 8, or 3 halves. So we're going to simplify as much as we can when we can. So that's just the expectation, right? At this level that we're going to definitely have radicals in our answers. Radicals are okay, fractions are okay. You're just going to have to use all that pre-knowledge of what you've learned before to kind of simplify as much as you can. All right, we have 2 word problems to do. And the word problems as it relates to trigonometry, they definitely follow a pattern. They use this whole angle of depression, angle of elevation. It is not my favorite terminology. I don't feel like we say that all the time in real world, and maybe pilots do when they're out flying. But usually this is what confuses students the most. So all it means the exact same thing in both locations. So the angle of depression is the angle formed with the horizontal, always kind of the same. The thing that makes it the angle of depression, not that it's sad, it's the angle formed with the horizontal when you're looking down. Okay? So think you're like up in a hot air balloon, or you're up in an airplane, or you're flying a UFO, whatever. Here is your angle with the horizon at that level. The angle of depression is just that looking down angle from your horizon, from your vantage point. It is going to be the same angle as the angle of elevation. It's the angle also formed with the horizontal, but you're looking up. Okay, so you're going to be looking up. So here's the horizon. When you look up from the horizon, that is the angle that you're going to form. That's what we're going to be looking for when we solve these word problems. So let's look at 2 word problem examples. I apologize, but I bet as we go through this unit, the lectures will be longer because we're playing catch up, right? I'm trying to put some extra stuff in here so that we can get caught up on last year. So an airplane is at an altitude of 24,000 feet, and the pilot sights the airport at an angle of depression of about 35 degrees. Find the distance from the nose of the airplane to the base of the airport. So let's fill out all the information we can. So when your pilot says that you're flying at an altitude of 24,000 feet, that's with directly kind of what your distance is from the ground. And our angle of depression from the airplane, right, is from the horizon down. So it's 35 degrees. Now we've got a right triangle, right? We see a couple right triangles in there. In fact, you can have kind of an upside down right triangle. Whatever makes the most sense to you. Here's our 2 different right triangles. What's the unknown? What are we trying to figure out? The hypotenuse, right? We're trying to figure out what our hypotenuse is. So here's the thing, right? We've got this upside down triangle, or I know students don't always end up using that. If we remember our parallel lines cut by a transversal theorem, then the angle of depression is the same as the angle of elevation from the airport. They mean the same thing, so don't let that terminology kind of trip you up there. So whichever triangle you're looking at, we have all the information we need. We have our angle, we have our opposite, and we're looking for our hypotenuse. So what trig identity do we use? The sine. Yep, the sine of 35 degrees is equal to 24,000 divided by your hypotenuse. Now in a previous example, we saw one just like this, and we did all the math to figure out how to do it. I would encourage you to use a shortcut. We've already proven that this works. What you just have to do is flip-flop those 2 things. If this is the problem you're trying to solve, right, it's going to come up probably half the time that this is how you're solving it. So your hypotenuse is equal to 24,000 divided by the sine of 35 degrees. So your distance to the airport, I got about 41,843, we'll just round to the foot. Anybody need help putting that in their calculator, checking? we have one more word problem to complete. I want to do this one because I think the homework assignment has one similar to this. I can't remember. So a person who is 1.5 meters tall, standing 20 meters from the base of a building. All right, so let's draw our person here. And he's 20 meters away from a building. I always encourage you to draw a picture. And he's 1.5 meters tall. That must be important for some reason. He sights the top of the building with an angle of elevation. So from his horizon, which is right here, oh, that was a bad straight line. So from his horizon, he sees the top of the building sighted at 58 degrees. So imagine he's got like one of those sighters, you know, and you're trying to figure out like the distance on like a golf course or something like that, and he's figuring out the angle. So that tells me when we're all said and done, we're going to have to add this 1.5 meters, right? That's the little trickeration ACT type question where we're going to have to add in an additional piece of information at the end. We want to figure out the height of the building. I'm pretty sure Mr. Howard had his trig students doing this exact same project recently. So I've got my angle, I've got my opposite, I have my adjacent, or I'm trying to find the opposite. So what trig identity do I use for opposite and adjacent? Tangent. So the tangent of 58 degrees is x divided by 20. We're going to just multiply both sides by 20. You can just type right into your calculator 20 times the tangent of 58 degrees. You get about 32. 32 meters. Now we've got to go ahead and add his height as well, right? He or she. So the building is about 33.5 meters tall.
Wow. I guess if it's 58 degrees, that's quite a while.
Okay.